Welcome to this tutorial on BiofilmQ. My name is Eric. Today I will show you how you can eliminate sample drift in your microscope images. Here I have the sample data, which we will provide you under the download link you can find underneath this video. If you watch closely, you can see that the sample drifts from one frame to another. This is not uncommon for time series, where the interval between images is in the range of hours. To correct this drift, you can use the image alignment, which you find in the image preparation step of the image processing pipeline. First, you have to make sure that all images are selected. The alignment also works on a selection of your images. Here we want to use all images. Therefore, we set the reference frame to the last time point. In most cases, the last time point is the best choice, since it eliminates the possibility that due to the sample drift, the image will be out of the field of view. You have two options you can pick for registration method. One is correlation-based, the other one is mean squares-based. The correlation-based approach is very robust even for large drifts, as long as your sample is in focus. If you don't have in focus images, the correlation algorithm struggles to find the perfect location. The mean squares registration method uses the MATLAB internal approach for registering images. It is quite robust for small drifts, and the images don't have to be perfectly in focus. If you want to align your images also in Z direction, you can use this checkbox here. This alignment in Z will always use the correlation-based approach. Continue existing registration offers the possibility to register the first half of your time series in a quick go, and then continue if you want to proceed. In most cases, it is more efficient to register all images in one go. You can start the process by pressing the Register Images button. A pop-up window will appear, which will show how much your sample drifted in each time frame. Here you can see that the sample started at the top right corner and then almost spiraled down to the last position. Here you can see what the reference frame means. The reference frame means the 0, 0, 0 position of this graph. The last frame, number 7, was in the origin of the coordinate system, and every other step was added according to this reference frame. You can now see, if you go through your images, that the images are perfectly aligned on top of each other. Just compare how much the sample drifted if we unselect the Display Aligned Image button. The image alignment is important for the time series analysis, and later if you want to create 3D renderings of your time lapses. For additional information on the segmentation process or the time series analysis, please consult the other tutorials or the online documentation.